Hi, can everybody hear me? Okay, is everybody ready? Was that break long enough? Okay, great. I'm Jamie Blair, test lead in WinSE. I actually own the GDR process from a test perspective, and own the BVT process, the integration team, stress, and functional BVTs for hot fixes. So I'll be going over the GDR process from the Windows perspective, how we release packages. So basically I want to cover the problem that we're facing, and why do we even care about a GDR? And I'll define a GDR in the upcoming slides if no one knows what a GDR is. So WinSE response, I want to talk about our process, the QA approach, what is depth testing, what is integration testing, what does it mean, call to action. So here's the problem. In the past year, I guess the past years, there's been an increase in incidents. We have NIMDA, Code Red, the SQL Slammer, Blaster. You have all these problems that you see in the press almost daily. There's a new problem out there and Microsoft is the fault. So what I'm trying to do and what you should try to do is, how do we not point to Microsoft as being the problem? How do we fix Microsoft, to make sure that we're not allowing these type of vulnerabilities to happen to us? It's a huge cost. The cost of every issue. Companies lose lots of revenue, productivity, bad press. That's the worst. You see it and just kind of drops you down to the floor. Reduced trust in Microsoft and ability to protect our customers. Customers lose faith. They think, wow, what's Microsoft doing to me? It's all our fault. So, cause. Basically, I'm going to give you a historical cause. We've done a lot to protect the customers lately in this space. But previous, let's take it back about a year or two ago. There were no real clear goals and expectations. There was a lot of misguided focus and priorities. Service pack is what we focused on. Let's focus on the service pack. Make sure the service pack is number one. When you put out a hot fix, get it to the customer as quickly as possible. And these hot fixes sometimes are rolled up into a GDR. That's a general distribution request. And it's basically a hot fix that goes to millions and millions of customers instead of just one customer. And so that's really where we should be focusing. That particular hot fix, especially a security patch, it should just work. The customer shouldn't have any fear that they apply this patch to their machine and it will break them. The worst case would be you apply it and you blue screen upon reboot and now you have no machine. Wow. We really can't afford to do that. So some of the problems in the past, and lots of effort again. I want to reiterate, we're really trying to get some progress in this effort. But we didn't have an organized QA approach previous to this process that I'm going to define. So, knowing that we didn't have a good process, we needed to basically set some goals. What is our goal? What are we trying to do for a security patch? And our goal is 0 recalls. We cannot afford even one. All GDRs must be tested to RTM quality. What is that? OS RTM. When I release Windows 2000 or Windows XP or whatever the great new operating system is today, it has to be as good a quality as that. Even better, I would say. And the reason I say that is a new operating system, people can test it, they can sort of slowly incorporate it into their networks, kind of test it out. Test the waters, and then roll it widely. But when it's a security release, you're limited on time. When we put out a patch, it's only a matter of, days before someone is reverse engineering that code and forming an attack, or a worm, a virus. So we really have to have better than RTM quality. Customers have to have 100% confidence that they can just deploy it right now and it will work. So what we did is we created a 5-week test cycle. It's actually not 5 weeks anymore, but I'll just give you some background. It was a 5-week test cycle, and when a particular security patch would go through the entire cycle, we would release at the end. Now we've promised to the world that we're going to release on every month. So we have to map this 5-week cycle to a monthly release. So there is overlap. You may have 2 cycles going on at the same time. So it's just not a 5 weeks and then another 5 weeks and then another 5 weeks. You may have 5 weeks to get something through a particular security patch, but there are other patches that are in progress. Other teams are working on them. They're being tested at the same time. So what it did for us is it streamlined our test resources and priorities. Everyone knew, okay, it's a 5-week test cycle. It is our security test cycle. And it is #1 priority for our business. So I know where we are with the timeline, which milestone are we at any point, at any time. And me, as a tester, I know what I should be doing at any given milestone. It improved the team focus. It's no longer a background activity. As I said before, in the past we were focusing on service packs only. That was our primary business model for sustained engineering. Work on the service pack, get the next service pack out, and it could take a year and a half for us to release a service pack. So a GDR would come along, you need to service some customer, or there's a new vulnerability. It's a background activity. Only the particular component which was affected was testing this particular patch. So you had some level of testing, but there are some components, when you change them, they break other components. There's dependencies. And this is what we're trying to address with this process. It also gave us a predictable schedule. Hey, we're doing this every month now. So that's pretty predictable. I know I'm going to be heads down in security stuff for months to come. And we have to target for the second Tuesday release. That's the message we've given our customers. We're going to release on the second Tuesday of each month. Team-wide sign-off. Instead of me as the affected component owner just testing, let's say, RAS, for instance, instead of RAS testing, the entire team is now testing their components along with this RAS change, making sure that the RAS change did not affect anyone in any adverse way, any other component, that is. QA approach. What we do, we have sort of 2 different ways of looking at it. We have component testing, and we call this depth testing as well. Depth testing is basically, I mentioned before, if I'm a component owner, we'll say RAS again. I'm going to pick on the RAS lead. But if RAS has a problem, only RAS has to do some work. They're testing, and it may take 3 weeks for them to fully test a particular fix in their area. What we're looking for is full service pack testing. And, that means different things to different components. It may just take a few days for some components to do a full service pack level of testing. So we keep all this information in the GDR checklist. It's pretty much the sign-off criteria for a GDR from a depth testing perspective. And I have the checklist I'll show you later in the presentation. And we also developed this test guide. The test guide is basically most of the detailed information that you would need in order to complete a checklist. The checklist is a series of questions that say, have you tested this in accordance with the guide? And it may link back to the guide. The guide itself has the more detailed information. But after you've done a few of these things, you start to understand all the particular questions. Ideally, you would read the guide first and then complete the checklist. And I'll show that later. And then we have a new model, which is integration testing. That's sort of what we've decided. This is what you get when you test a service pack. You have every component testing their respective component on all of the fixes at the same time. So we have the integration coverage in a service pack model, and we call this the broad test pass for the GDR program. That's when all components are testing for a period of a week, generally, on their functional areas. So what you see here, this is basically the security cycle end to end. And I've broken it down. It used to be a 5-week process, so we have 5 milestones. It may not map directly to a week anymore, given our month-to-month release that we do today. But these things have to happen generally in this order. So the slide still works. But basically, in the first milestone, we're trying to achieve what are we taking for this particular test pass? What's identified to go in this test pass? We decide that by the priorities set by MSRC. That's our Microsoft Security Response Center. They'll say, hey, these are the #1 priority things that we think should be targeted for X date down the road. And so we'll map it to a particular test cycle where we expect to have a release on a given date. So what we're asking for, you put the fix together. We determine if we're going to accept the fixes, they have to have certain things like dev template, and you'll probably understand some of this stuff from one of the other presentations. I'm not going to go into all the requirements of Product Studio and how we get bugs accepted. I'm sure that's covered in a different one, probably by Sid. But we set the GDR groundwork. We find out who all is going to be included in this package. If I take a fix to RAS, maybe RAS depends on kernel. So maybe we have to ship those 2 binaries together. It doesn't, but it could. And that would be a dependency, which I'll get into in a different slide as well. But so you need to involve the kernel dev and test, and you need to involve RAS dev and test. Get together, find a good plan that works for each component area. Once we know what that is, what is the impact? You can kind of calculate, okay, if RAS testing takes 3 weeks, kernel testing takes 1 week, RAS is the long haul. It's the schedule that we should be looking at. If it takes 3 weeks, are we going to be able to make the broad test pass? Are we going to be complete by the broad test pass so that we can actually, include this for a given test cycle? So then we have WAR approval, and we check in the fix. We build a package. That's pretty much the cutoff. We're saying we cannot accept another package, because if a package wasn't built by this time, there's really no way to get full testing complete by the 5th week, or the broad test pass, as we call it. So moving on to milestone 2, actually, let me just flip to a different slide. So this may be easier to see. I covered milestone 1. Milestone 2 is basically, we've completed the BBTs. That means we have a package. The build team, they created a package for us, and we've taken it into BBTs, and we tested all the packages according to their respective language and their platform, x86, IE64, NEC98. Then moves on to functional BBTs and the hotfix quality team. The first two teams are my team for integration, actually. Then component testing starts. Component testing, they're just going to get a package, and they want to make sure that their binary lands in the system in the right location, and then they want to test the way they know how. They don't know specific information about the package for the most part. The experts are, package-specific things. That's why we have the BVT process. But they know functional testing better than anyone, so they know how to test the RAS binary in this case. And they'll pretty much complete a sanity level of testing at this point before we kick off stress and self-host, because they want to understand what these changes mean. I mean, it could break them right away. And if it breaks them right away, no need to run stress. Let's get it back in, get a new package built, get a new fix. Moving on to milestone 3, pretty much at this time, for depth testing, your Prime 1 tests are complete. We have lots of parallel processes going on at this time. We're trying to get these bits ready for WUPM, and how are they going to get uploaded into Windows Update. We're calling a security GDR beta. We have a patch validation program that actually kicks in, and we have some external customers signed up to actually validate these patches for us. And we're creating the sign-off pages for when we go live. We want to make sure everything is checked off. We've crossed all the T's and dotted all the I's. Then we hit milestone 4. Your in-depth testing, your component testing, should be at least half complete, and even more so. This was a sort of a loose bar. I think you really need to have your component testing underway during this milestone. Before we hit the broad pass, you should be almost done, because that's maximum bang for the buck. The entire test team is going to be testing these bits when it comes time to the broad test pass. So if there's still an issue that you didn't find that you could have found, I mean, think of the man hours you're wasting. Everyone testing this package that was actually bad that you could have caught this first. So we begin the security deployment, which is I talked about earlier. WU testing, they're actually testing the bits, making sure all the right things happen. A broad mail goes out to the team. We're announcing, here's the contents for this upcoming test pass. Here's what is in it, and these are the new requirements. We keep changing requirements almost every test pass. So as we find new holes in our process, we'll try to close those holes with new processes. And we'll announce that broadly to the team. OTG, looks like I left it as ITG. They keep changing their name. I think they're actually MS IT at this point, but it's our internal deployment group. There are infrastructure servers and clients. They keep Microsoft running, so they actually share deployment with us, and they will load these patches onto their machines. Then we begin the broad pass, and the broad pass is, like I said before, I've kind of touched on all these things. That's everyone testing their specific components with all of the packages that are slated for release. We may have 4 packages that are going through this, and they're going to be released at the end of some test pass date. So what we do is we call these TP. It'll be like TP and then some number. Test pass 1, test pass 2, test pass 3. We're actually working on test pass 12. So then the broad pass begins. Everyone's testing. We're looking for sign-off across the board. And that sign-off basically is saying that I have validated that all of these patches installed at the same time. I've run my area testing, DBTs, kind of sanity plus. And I have found no issues. So you sign off. At that point, the package handoff to Windows Update, and the package is shipped. So back to, that was the overview of the process. What we've done is we've increased the component testing with the guide, as I've already touched on a little bit. the guide was basically defined from the service pack criteria, the release criteria of a service pack. We took that, put it on paper, and we said, okay, how can we ask some questions around all of this criteria? And then we put the detailed information around each one of those questions on the how, and that's in the GDR guide. And the checklist is those series of questions that I discussed. But it's the steps you need to follow when you're testing a GDR. It kind of it helps you stay on track so that you don't miss something. And when you see it, you'll know why we created it. Because there's lots of steps. There's lots of pieces, and everyone's important when you're talking a security patch. And it's very easy to forget one of these steps. So having it here, having someone responsible to answer these questions, that helps us do a good job. So that was our first crack at improving the security business. Let's come up with a standard criteria of how we're going to test these patches. We implemented this in early 02, and it improved the quality, but we still had recalls. And we're trying to think why. Why do we still have recalls? So the second look at why we have the recalls, we start looking at the service pack model again. We have less recalls on a service pack, so let's think about that. That's the integration testing. We think broad test coverage, all components, stress, self-host, deployment. These are the things we were missing. We were just leaving it to one specific component area to own the entire release for that particular package. So the integration testing, the benefit is we find regressions due to system dependencies. So dependencies their file dependencies require testing across multiple components because your fix may span multiple binaries. And I touched on that earlier as well. But we have a lot of dependencies today. And what happens, as you make fixes, as customer requests come in, you'll continue to fix a particular binary, and that may create a dependency here and there. And now, when I'm shipping that particular fix to a down-level platform, because we support service pack N and N-1, N meaning the last service pack that you release. So supporting the last service pack, that's not such a big deal, but when you go N-1, that's a lot of changes. You have to take all the changes of service pack N and add that with all the changes in the current source tree. And there's a high likelihood that there will be a file dependency created where you need two files to make one fix. Now both of those files have to come together in the package when you're deploying it to N-1. So functional dependencies, they require system-wide testing. One component could depend on behavior of another function somewhere else in the system. And if you change that particular function, now you've broken that behavior. It expected this, and now you get something else. A good example, and I'll help you understand this with, this happened in RAS. There were one RAS binary. There was a function call that basically linked two RAS binaries together. We added a parameter in one of those binaries, or one of those functions, let me say. And so now we had three parameters in one function in one binary. The other binary was already shipped, so it's lying out there on somebody's machine. So if you ship only that binary, now the binary on the customer's system is expecting two parameters, where now you're giving three parameters. So the two binaries don't talk anymore. Shipping both binaries is the way to solve the problem. Okay. So component testing of the modified function doesn't always cause this regression, or catch this regression, let me say. Sorry about that. File dependencies. More about dependencies. Many other presentations will talk about dependencies as well, but a fix can span multiple binaries, and here's an example. You can see SP2 would require all of these binaries, A.dll, B.dll, C.dll. The reason is, we've taken changes in SP3 that created dependencies, and then, we ship another dependency was added in SP4, and so we're shipping out of the current service pack tree, and in order for service pack 2 to function properly, and we explain the dependencies on the left-hand side, how they were created, and it's generally created on a customer fix. That's how we get into the mess. Some customer is broken, and we say, we will fix you up. Here you go. Here's a fix. And what happens over time, you start building these dependencies. We're very aware of dependencies now. We really try to minimize the dependencies, but there are some fixes where they require changes in multiple binaries. That's the only way to make the fix. And compound this problem of dependencies across the support matrix that we have. Look at Windows 2000. You can see we have one platform for Windows 2000, but we have 2 languages that we support here in Redmond. And of those 2 languages, we have 2 different package types. We have a full package and an express package. And then we have to support those packages on the different service packs that I discussed. We actually have a model right now where we support N-1, and N-2 for for Windows 2000. And that was due to customer demand. Customers needed more time, and there are still a lot of machines running Windows 2000 Service Pack 2 out there. And our commitment to our customers, we'll support it for security patches only. Our standard support policy for a QFE or a hot fix would just be N and N-1. And then you look at Windows 2000, you have 2 platforms, the same 2 languages, and the same 2 package types. The benefit on Windows 2003, I think I said 2000. I meant 2003. The benefit of Windows 2003 is we only have Service Pack N right now, but as soon as we release Service Pack 1 for Windows 2003, this matrix will get compounded. It will become larger, very similar to the XP in the Windows 2000. So, call to action. You're responsible for the quality. And, I'm responsible, you're responsible. It's very important that we really take this seriously, especially for a security patch. We just can't afford to go wrong in this space. Developers, we need the developers provide accurate fixes, do proper code reviews, engineering reviews, architectural reviews, dev templates assigned, help test, define what tests they need to run based on the fix, work with testers, do full regression testing on the impacted, encompassed, and dependent changes. Fill the GDR checklist. A well-defined sanity pass. When we're doing the broad pass, make sure you're doing enough testing. You're responsible for 0 defects, 0 recalls. Leads and managers, be responsible for the checklist contents. If you have employees that are actually filling in the checklist, it is your obligation to review that checklist. Make sure they've filled it out correctly. You understand the contents of the checklist, and as you will be signing off on the checklist. Program managers, help define, drive the broad test pass, and coordinate the beta programs, sign off, release. So here are some references, and you all have the handout. So feel free to contact me at any time. If you have any questions, it's J. Blair, and I'll be more than willing to answer those. But I want to take you to a demo before we get into questions, so I talked a lot about the GDR checklist. So this is where a tester would come in, and as they're testing, they would update the status. So let's just go through what we have here. This master page that you're seeing, it basically gives an overview of the contents of the checklist. This one in particular is 100% complete for the checklist sign-off. Then we have a checksums imported, 75%, install variations 83, and functional test sign-off is 100%. You have a little bit of bug details. What is the bug number? And this bug is the Windows SE database bug number. You have the title of the bug, the particular platform, and the milestone. And then you have an owner. And this owner generally comes from the test engineer field in Product Studio. So the very first thing that a tester would do is they would come here. They would see a bug. As long as they're the owner, they would come to this page and they would see, I have this particular checklist assigned to me. And then they can click on this checklist and it brings them to this page that you're seeing now. So the checklist, and it's kind of small. I don't know, the folks in the back might have a hard time. But I'm not going to go over every question in the checklist. But what I will talk about is how we break down the checklist. The first 4 questions are pretty much like, they're just pre-install questions. And this is, you're looking at the contents of the package. You're making sure it has the binaries that you need and want. Make sure it's all inclusive. And then we go into install tests. We go into post-install. We actually do install and uninstall testing. And then it gets into functional testing and then the test buckets. And the very last thing on the checklist page is lead sign-off. And the lead sign-off, some of the important pieces here are, did you verify the checksums? Because when you go to release this particular GDR, it should match what was tested. It would be very bad to spend all this time testing and then we pick up the wrong package to release. Because we build multiple packages. I mean, it's not just a single unit. If everything went well, it would be a single package. But generally, this is, software engineering, we will have problems. And you're verifying that the checklist is correct. You're signing off on the checklist. So this is the overview page. Now we get into the details of the actual checklist. Checksum page should be filled in automatically. We have a functional BVT, not functional, install BVTs. And this particular test was designed by our setup team, so they understand installation, setup. And what will happen during this test run, it will go out and grab the latest package. It will show you the MD5 checksum so that you know this is what you can compare against when you're actually trying to sign off. So this really long number and letters, it's the hash. And you have packages. You have packages for English x86 full. You have English x86 Express. They're 2 different packages. And is everyone familiar with the types of packages? Has that been already given? Express versus full? Okay. So I won't go into that. And then we have German, Express, and full. Scrolling down, each package is now broken down into the individual binaries. So we have the checksum of the individual package, and if we were to rebuild that package, that checksum would change. But you can also look further into the actual binary, the file version, the binary name, the checksum, for individual packages listed above. This information, like I said, should already be there. And if it's not, you can contact me, Jay Blair. Install variations. The install variations, this is installation testing and uninstall testing. Pretty much, like I said before, the setup team wrote this series of tests that they feel are applicable to every package. Verifying the symbols, sanity check of the INF, verifying trusts, installing the package, verifying no event viewer messages, unexpected event viewer messages. Verify no invalid hotfixes are installed. It validates the files in the package, uninstalls the package. Then it does the same series of tests. Looks at the event viewer, makes sure there's no new messages after uninstall and install. It does a series of times. Looks like it goes through that about 3 times. So this information is already filled out. If it's a pass, we'll basically import the data from this test harness automated way. You'll get the result and it's passed. The tester now would check these particular boxes here that correspond to the test that were run below. And we're working in the future. You won't have to do that. But it does give another set of eyes to validate that what happened with the automated testing is the right thing. There could be one of these variations. Here you go. That's a good one. So we have a failure, right? And so you wonder, why would you sign off on that failure? You know, there should be justification as to why this failure happened. And, you know, we would need to investigate that, and we should add comments to the GDR checklist of why this failure happened. Next page, functional testing. Basically, these are the variations that you're responsible for. This is a full depth test pass that we're asking for. And you can see this particular package is a Windows 2003 package, which is a dual branch package. You have a GDR branch binary and you have a QFE branch binary. And so are you familiar with the dual branching concept? Yes, okay, great. Won't have to go into that. Okay, and then the service pack. And so it's particular, you don't have to test 7 and 8. What we're using is pairwise combination to sort of take the combinations of OSs, platforms, languages, service pack values that you're responsible for and try to create maximum coverage with minimal variations. And so we're actually trying to optimize here because we realize the amount of work that's involved. Then the encompassed bug tab. Okay, this particular package had no encompassed bugs. If it had encompassed bugs, meaning an encompassed bug, if binary 1.dll ever had a fix, then you should see, since the last RTM, you should see those fixes listed, right? So maybe a customer asked for a fix in that particular binary once before. So if that happened, you would see another bug here. So that means you're testing your bug. You're also validating the other bug that's encompassed in your binary. And then you're signing off. So the way to edit the checklist is you click on the lock button, and then it unlocks the checklist for you. And it allows you to enter data. When you're done, you hit save, and you lock it again. So I'll just lock. So the checklist, back on the very first tab, the thing I didn't talk about was the guide, which we touched on earlier. You'll see a lot of hyperlinks for every one of these questions. The reason it's hyperlinked, let's say I can click on this, and it redirected me to the site where I can get the information for that. The question that I clicked on was, did it pass QFE quality test sign-off? So it redirected me to the QFE quality test website where I could put in this particular bug number and see if the functional BVTs had passed. Now, this particular entry that I just clicked on was validating the INF, or verifying the package. It's going to open up the GDR guide to the appropriate bookmark, verifying the package content. So you can read about it that way. So the guide is our comprehensive test manual for a GDR and a package. Pretty much tells you everything you need to know. If there are any problems, any questions with the guide, I'm the man. So send mail to me, and we'll get that addressed. So open to questions. Great. You guys know everything about it. That's good. No questions? I didn't confuse anyone? Okay. Well, thanks. Thanks for coming.